Hi guys, Spas here. So today I want to present you the second part of our solar diverting system, the IoT TRIAC controller. If you don't know what TRIAC is or the SCRs, how they work, I will make sure to link some good videos explaining how they work and what they are used for. But in short, the TRIACs are devices that allow us to regulate how much power is delivered to some kind of load. So, what are the main features of the device? It's also based around ESP32, just like our power meter before that. It has powerful TRIAC that could handle up to 40 amps at 600 volts. It's also used 2.4 GHz Wi-Fi for its use at home, just like our previous devices. It doesn't require any additional cabling for control and monitoring. It uses MQTT, so it's easier to integrate in already existing home automation systems. It has web interface for configuration, and last but not least, it has its own temperature monitoring of the thyristor. So in case of overheating, it will just shut off. What's the intended application of that device? It could be used like any other dimmer, but way more powerful. So it could handle something like 8 kilowatts of load. But the main feature, the main intended application of that device is to be the regulating component in our solar diverting system. A little background about the solar photovoltaic systems. In our applications, the easiest approach is to use the so-called grid-tie inverters that are working in parallel with the grid. The grid-tie inverters are really good for home applications because you don't have to cover all the consumption with the photovoltaic. If the consumption is over the available energy, you will just get it from the grid. But what happens when you have more power than the consumption? The first option is to export it to the grid. That's the best option because you're not covering only all the consumption that you have, but also getting paid for the any excess energy. That's great, but not always available. It depends on local law, distribution companies, and so on. In some countries, it's just straight illegal. The second option is to install power limiter. That device keeps the output power of the inverter up to the consumption. You will cover all your consumption, but without any export. And the last option is just to keep the consumption higher than the production. Here, our system comes into play. By measuring the input power from the grid with the power monitor, we know if the inverter is limiting its output power. Normally, the grid-tie inverter keeps a minimal consumption from the grid in the range from 5 to 50 watts. Knowing that value and the current consumption from the grid, we know if there is more available energy, so we could divert more energy to some kind of load. For example, we can increase the power through the power regulator to a water heater and keep the consumption from the grid at 100 watts. That will guarantee us that we are using all the available energy from the photovoltaic and limiting the imported energy. Now, if something is consuming a lot of energy, it's switched on, we will detect that in the consumption from the grid and it will reduce the power to the water heater. After that it's switched off, we will increase back the diverted energy to the water heater up to the production of the solar system. And in that way we will keep the balance of the system, using all the available energy from the solar system without using a lot of energy from the grid. Some real-life data from one of our test sites. Here you can see the consumption from the grid and the percentage that's used to control the power regulator. As you can see, the power consumption is kept at 200 watts, but all of the house is dynamically loading and unloading the solar system, so it's moving around a lot, and the regulator is keeping around 36%. Here the load is 4 kilowatt water heater, and also you can see here we have a second load that's currently switched off completely. That's because there is a way to prioritize different loads. And also we have a possibility to use a force command to switch on the water heater. In case there is some kind of rainy day, just like today, I can just switch it on completely. And you can see the power consumption from the grid skyrocketed. If I completely switch it off, it takes some time to, now the second consumer is switched on, but I don't think that there is a watt connected to it right now. If I switch back to automatic mode, it will take some time. Yep. Now back at 200 watts. Switched on again. 3 kilowatts from the grid, and maybe around 1 kilowatt from the solar system. Turn it off. There is no watt connected to that regulator. Turn it on back on automatic mode. Takes some time to get regulating correctly, but yeah. So from one of our longer running test sites, we already have some initial numbers. Normally on that site we were producing something like 150 kilowatt hours per month. With that setup we got to up to 250 kilowatt hours per month. Currently we're testing the whole system on a couple of different locations. For now the results are really promising. I can share super precise numbers, but for the last 2 to 3 months the produced energy at the test sites is increased with 40, 45 up to 55%. So yeah, it's working as intended. Soon we will start a campaign on Indiegogo to fund the mass production of the devices. I will update the video description when that's available. So that's all for now, guys. Subscribe to our channel for more video on IoT topics and information for our other products. See you, bye!